Hello everyone. Today's topic is misconception in chemistry. In this topic, I am going to discuss on the misconception to how draw the organic molecules correctly. Here I am going to show you some examples of organic reactions where students have drawn the organic molecules but the bonding pattern is wrong. Now let's start the discussion with this example. This is the reaction is written by students. Tertiary butyl bromide when reacts with sodium methoxide, it gives this product. First of all, this product is wrong because when the tertiary butyl bromide reacts with sodium methoxide, here elimination reaction takes place and we get an alkene product instead of nucleophilic substitution product. And here is another mistake is the bonding pattern. Now if you look at the structure of the product, here you can see the bond is between carbon and hydrogen. This is wrong. Bond should be carbon and oxygen. Not carbon with carbon or carbon with hydrogen. It should be carbon with oxygen. Now if you think that sodium methoxide is acting as a nucleophile, then here nucleophile is O CH3 minus and electrophile is 3-degree carbocation. Now nucleophile will attack to the carbocation and we will be getting this product. So now here you can see from the reaction mechanism, it is clear the bond is between carbon and oxygen, not with the carbon-carbon or carbon-hydrogen. Now this is another misconception. So this is a reaction. Here alkyl bromide reacts with potassium ethoxide. So it will be a elimination product. So product is correct. But the bonding pattern is wrong. So here you can see the bond is carbon-hydrogen. But actually the bond will be carbon-carbon. So either I can draw the structure in this way C2H5 or I can split the structure and I can write carbon CH2CH3. So this carbon will be sp2 and this carbon will be sp3. So when we are drawing the structures, we have to be careful that what is the bonding pattern. Now again another example. This is one of the structure of acid molecule. Now if you look at the structure, you can find out where is the mistake. So here C double bond O. So here the bonding is CHO. So that means bond is carbon and hydrogen. That is wrong. In acid functional group, the bond is carbon with the oxygen, not carbon with the hydrogen. Now here in this reaction, chlorobenzene undergoes sulfonation and here you can see the bond is carbon with the hydrogen. Here also carbon with the hydrogen. So bonding pattern is wrong. So correct bond should be carbon with the sulfur. So it is SO3H. So carbon will be making a bond with the sulfur, not with the oxygen or not with the hydrogen. So why carbon is making a bond with the sulfur? With the reaction mechanism we can explain it. Now this is the reaction mechanism of sulfonation reaction. We know for the sulfonation reaction we use sulfuric acid, concentrated sulfuric acid and sulfur trioxide. So concentrated sulfuric acid is a strong acid, so it will give the protons, and now this proton will be attacked by the oxygen lone pair of sulfur trioxide. Then we are getting these two compounds. Now this molecule, the electrons will move in this way. Now here you can see the sulfur is getting a positive charge. That means this molecule is now acting as an electrophile. Now benzene will attack the electrophile. So electrophilic center is sulfur. It's not oxygen, it's not hydrogen, because sulfur is positively charged. So that's why double bond will attack to the electrophilic center, and this is the iridium ion. Then finally after the deprotonation, aromaticity will gain and we will be getting the final product. So from this reaction mechanism, it is clear that due to sulfonation reaction, the bond forms between carbon and sulfur, not carbon with oxygen or not carbon with hydrogen. So remember, misconceptions are the barriers to understand the science. So we have to clarify the misconception. I hope you like this video, and if you think this video is useful for your study, then share it and subscribe my channel Chemistry Affinity. If you have any queries related to chemistry, you can send me a mail chemistry.affinity@gmail.com. Thank you.